unit magnetism part 2, especially class 8. Okay, I am going to write down some questions and answers. Question number 1. See, mention some measures to increase magnetic force or to conserve magnetic force. How to conserve magnetic force? That means magnetic force can be conserved by the following ways. This is the demagnetization is the problem. How to solve demagnetization? Now you have to write down the answers of this question. Magnetic force or strength can be conserved by the following ways. Number 1, by keeping magnetic bars. By using or by keeping magnetic bars, they keep the magnetic force and they increase the magnetic force. Another, by not rough handling or by using magnets properly. We have to use the magnets very properly without harming. Another, by not rough handling, by not rough handling. Rough handling demagnetizes magnetism, but by not rough handling, by not dropping, not heating, and not passing alternating current. By not passing alternating current, because by passing alternating current it demagnetizes. So by not passing alternating current, in this way we can keep or we can increase magnetic force. Question number 1 today. Question number 2 is state scientific reasons. Say state reasons. Number A, repulsion is a sure test of magnetism. Attraction is also, but repulsion is a sure test of magnetism. How to know repulsion is a sure test of magnetism? Like poles repel. Like poles repel and unlike poles attract each other. If you take a magnet, see this is a magnet, this is a magnetic substance. Which one is a magnet and which one is magnetic substance? Suppose it is a magnet and suppose it is an iron rod. They look alike, but how to know which one is magnet, which one is an iron rod? Attraction method is also okay, but repulsion method is sure test. If it is a magnet, there is no magnetic force in the middle. If it is an iron rod, there is force, there is magnetic attraction, there is attraction. In the middle of a magnet, there is bar magnet, there is no attraction. but there is attraction everywhere in an iron rod. In नेपाली म्याग्नेटको छेउछेउमा म्याक्सिमम फोर्स हुन्छ, बीचमा हुँदैन, नो फोर्स. आइरन रडको सबैतिर फोर्स हुन्छ. Which one is magnet and which one is not magnet? How to know? By repulsion method. Like poles repel and unlike poles attract each other. So repulsion is a sure test of magnetism. There is another method of testing a magnet: directive property, attraction property, and repulsion attraction property. But we can apply the directive property or test, because a freely suspended magnet always shows the north-south direction. So if this rod, an iron rod, does not show any proper direction, any fixed direction, but a freely suspended magnet always shows the north-south direction. So it is sure that this iron rod, it is not a magnet. A magnet always shows the north-south direction. Another, the magnetic force is maximum at the poles and minimum in the middle of a bar magnet. How to classify it? How to prove it? See, how to prove that the magnetic force is maximum at the poles. At the pole, north pole and south pole, maximum, but in the middle, minimum. See, in the middle, what happens? At the poles, what happens? The poles, here north pole and south pole are free, they are free to attract. North pole is free to attract, the south pole is also free to attract, but in the middle, what happens? In the middle of a bar magnet, the total magnetic force is 0. The total magnetic force is 0. That means the total magnetic force due to the north pole and due to the south pole is 0. So magnetic strength is maximum at the poles and minimum in the middle of a bar magnet. छेउछेउमा फ्री हुन्छ, बढी हुन्छ, बीचमा चाहिँ इक्वल एन्ड अपोजिट. The force is equal and opposite. Therefore, force cancels by cancellation. Question number 2A, B. Question number C. Keepers are used in a magnet box or with the magnet. What are keepers? Keepers are actually steel rods which keep the magnetic force. Which keeps the magnetic force in a proper way. See, keepers or steel bars. Steel bars are used to avoid demagnetization. To avoid demagnetization or not to demagnetize. To avoid demagnetization or increase magnetism. Increase magnetism. If they are not used, if keepers are not used, what happens? The magnet loses its magnetic force. Keepers are used to avoid demagnetization or increase magnetism. So, the keepers are used because they keep the magnetism for very long time. There is another question. Uh, see, another question is by heating a magnet demagnetizes on heating. On heating, it demagnetizes. How? On heating, what happens? There is expansion. Heating causes expansion. Heating causes expansion. And what happens? What else happens on heating? Heating causes, first of all, heating causes expansion. And the molecular magnets are disturbed. What happens? The open chains become closed chains. That means the open chains called regular patterns. Open chains become closed chains as the molecular magnets are disturbed. Their positions are disturbed. Therefore, it loses. On heating causes demagnetization. Question number 3. See, state Weber-Ewing molecular theory of magnetism. Molecular theory of magnetism. You can state the molecular theory of magnetism in 4 points. The molecular theory of magnetism. First point. What is the first point? The first point is every magnet each and every magnet has 2 poles. Every magnet is made of magnetic materials only. Only magnetic materials are used to make a magnet, or poles cannot be separated. It means the poles can't be separated. Number one. Number two, in an unmagnetized form. What happens in the unmagnetized form? See, here it is written in another way. It has molecular magnet. Means it has molecular domains. Means smallest possible magnets. Smallest possible magnet. One magnet can be broken into many. It means a magnet can be made from magnetic bodies. Another, a magnet can be broken into many or infinite numbers of smallest possible magnets called molecular magnets or molecular domains or magnetic molecules. Now, in an unmagnetized form and magnetized form. The unmagnetized form, I draw this is a magnetic body, but not a magnet. In an unmagnetized form, what happens when a magnet or is not magnetized, not magnetized, or it is better to write when a magnetic body is not magnetized, or in an unmagnetized form, what types of molecules are there? Irregular molecules called closed chains. Closed chains are formed and they attract each other. They are free to attract. All the molecular magnets attract each other and there is no magnetism. So there is no magnetism. The magnetic force is zero. But when the same magnetic material is magnetized, what happens? When a magnetic body is magnetized, what happens? The closed chain means irregular pattern. The closed chains become open chains and magnetism is developed. In number one, every magnet is made up of magnetic materials only. We cannot make magnets from non-magnetic bodies, and each and every magnet has two poles. Number two, it has molecular domains, means we can break a magnet into many or an infinite numbers of magnetic domains, molecular magnets or smallest possible magnets. Number three, in an unmagnetized form, what happens? There are irregular patterns of molecules. Irregular patterns means closed chains, therefore they attract each other and there is no magnetism. Number four, when a magnetic body is magnetized, the closed chains become open chains. This closed chains become open chains like this. Closed chains become open chains like open chains. The closed chains become open chains. This is the difference between a magnetic body and a magnet. A magnetic body has closed chains. That means the molecules are randomly placed. A magnet has open chains. That means the molecules are facing in a regular pattern. All the north poles face in one direction, all south poles face in another direction. This was for today.